Good day everyone, I'm Spectroscopy and my metric ID is SA23043. Today I'll be presenting question 1 which involves analyzing a compound based on elemental composition and UV visible spectroscopy data. We are given the following percentage composition where carbon is 66.6%, hydrogen 11.1%, oxygen 22.3%. Assuming a 100-gram sample, we first convert this percentage to moles, where carbon 66.6 grams divided by 12 gram per mole equals to 5.5 moles. Hydrogen 11.1 gram divided by 1 gram per mole equals to 11.1 mole. And oxygen 22.3 grams divided by 16 gram per mole equals to 1.39 moles. Next, we divide each mole value by the smallest, which is 1.39. So as for the carbon, 5.55 divided by 1.39 equals to 4. Hydrogen 11.1 divided by 1.39 equals to 8. Oxygen 1.39 divided by 1.39 equals to 1. So the empirical formula of the compound is C4H8O. Moving on to the UV spectroscopy part, the compound shows an absorption band at 275 nm with a molar absorptivity of 70. This low intensity indicates the non-conjugated chromophore, since strongly conjugated systems typically have much higher Emax values. The absorption at 275 nm and low Emax are characteristics of an N to N-type transition, which is typically for carbonyl-containing compounds such as aldehydes and ketones. This transition involves the excitation of a non-bonding electron to an anti-bonding N orbital. So for more explanation on this, I would like to pass it to my next group member. Thank you.
Hello everyone, my name is Gayatri Udayakumar. My metric ID number is SA23026. Today I will continue presenting question 1, which is how we identify an unknown organic compound using FTIR and proton NMR spectroscopy. First, from the FTIR spectrum, we observe 3 key peaks. A peak around 2941 until 2957, which indicates the presence of CH stretching, suggesting alkyl groups. Next, a strong peak at 1715, which clearly confirms the presence of a C double bond O stretching, indicating a carbonyl group such as a ketone. Then a peak at 1460, which shows CH2 bending, further supporting the presence of alkyl chains. From this FTIR data, we predicted the compound could be a ketone with alkyl groups. Next, we analyze the proton NMR data. There are 3 signals. Firstly, 2.48 ppm integration of 2 a quarter. This corresponds to a CH2 group adjacent to a CH3 group. Then 2.12 ppm integration of 3 a singlet, where it assigned to the COCH3 group, meaning a methyl group next to a carbonyl. Lastly, 1.07 ppm integration of 3 a triplet, where it assigned to a CH3 group coupled with CH2, indicating an ethyl group. By putting all this together, we see that the compound has 4 carbon atoms, a ketone group at carbon 2, and ethyl and also methyl groups on each side. Based on both FTIR and also NMR data, we conclude the structure is butane 2-on. That's all from me. Thank you. And that's how we use both FTIR and NMR to successfully identify the unknown compound as butane 2-on. Now, the next person will continue the next part.
Hello everyone, my name is Kirtiswaran Murali. My matrix number is SA23005. And let's move on to question number 2. The information given, and we have to predict the molecular structure of the compound. So based on the information given and based on UV-Vis, a peak was observed at 268 nanometers, which is typical for a pi to anti-pi transition found in aromatic systems. This absorption occurs at slightly higher wavelength than the unsubstituted benzene, indicating the presence of electron-donating substitutions such as methyl groups. These groups extend conjugation and cause a bathochromic shift, confirming a substituted aromatic ring. Meanwhile, in IR spectrums, the absorptions in the range of 3067 to 2907 inverse centimeters were consistent with CH stretching vibration, both aromatic and aliphatic hydrogens. Additional peaks at 1608 and 1473 inverse centimeters correspond to the aromatic carbon double bond carbon stretching vibrations, which are the characteristics of a benzene derivatives. Together, the UV and IR data provide a strong evidence for an alkyl substituted aromatic compound, guiding us towards the correct molecular structure.
Hi everyone, my name is Yap Yuzhen, metric number SA23025. Now, I will explain about how to predict the molecular structure based on the NMR spectrum and also the molecular mass. So let's start with the NMR spectrum. So from the result, we can see that there is a peak at 2.26 ppm with the integration of 9 and multiplicity which is singlet. The peaks appear at 2.26 ppm shows that it is the hydrogen atom from the methyl group, where the methyl group may be close to the electronegative atom or the electron withdrawing group. And the integration which is 9 shows that there is 3 CH3 present in the compound. And the multiplicity which is singlet shows that the methyl group may be bonded to the adjacent group which has no hydrogen atom, or it may be bonded to the benzene ring. So this peak indicates the 3 CH3 is present in the compound. And another peak appears in 6.79 ppm with the integration of 3 and the multiplicity which is singlet. So the peak at 6.79 ppm shows that it may be the hydrogen from the benzene ring. And the integration which is 3 shows that there is the 3 hydrogen atom which is bonded at the benzene ring. And the multiplicity which is singlet confirms that the benzene ring is present in the compound. So this peak indicates the benzene ring is present in the compound. Based on the result from the NMR spectrum, we predict that the molecular structure is 1,3,5-trimethylbenzene. This compound has the benzene ring which is attached by 3 methyl group. And based on the molecular mass of the compound that we predict has 9 carbon atom and 12 hydrogen atom. And the atomic mass for 1 carbon atom is 12 gram per mole, and for 1 hydrogen atom is 1 gram per mole. So the molecular mass of the entire compound is 120 gram per mole. So this is same as the molecular weight that is given from the question. So it confirms the structure that we drawn is the trimethylbenzene. Thank you.